Hey everyone, welcome back to video 8 of understanding VXLAN using BGP EVPN. Again, this is part 8. I wanted to go over again the RD and the RT. So the difference between the route distinguisher and the route target. It's very easy to confuse them because they both use the word auto and they both involve tagging a route. But in the BGP instruction manual, they have two completely different jobs. So here in the VRF, you see we have both the RD and the RT. Think of it as a difference between a unique ID card, which would be the route distinguisher, and security clearance, which would be the route target. Okay, so again, route distinguisher, or the identity, or the unique ID card. The route distinguisher's only job is to make sure that if two different customers are using the same IP, like 10.10.0.50, the spine doesn't get confused. You may ask, well, how can that happen? You can only have one IP, right? Well, remember that the VRF, you can have multiple VRFs and you can have the same IPs on those VRFs because each of them will be its own distinct routing table. So local to the switch, the route distinguisher is like a serial number. Every switch uses its own router ID, like 11.11.11.11, right? So you can have the router ID being the same on every single VRF. The second part of the route distinguisher is going to be your VRF, right? So it's going to be the VRF VNI. So if you have multiple tenants, multiple VRFs, and well, actually it's going to be router ID, or sorry, route distinguisher is going to be 11.11.11.11 for VTEP1 colon 50,000. If you have another tenant that's 80,000, then it would be 11.11.11.11 colon 80,000. The second half makes them unique on the switch. So on the spine's perspective, it receives these updates. It sees, for example, let's say we do have two tenants, right? It sees two different BGP prefixes because the route distinguisher is prepended to the IP. So let's say for VTEP1 going up to the spine, on the spine it would read something like 11.11.11.11 colon 50,000 colon 10.10.0.50. And if we had a different VRF, then it would read it as 11.11.11.11, and let's say that VRF's VNI is 80,000, then it would be 80,000 colon 10.10.0.50. So because of the 80,000, it's going to know it's on a different routing table, and they'll be unique. To the spine, these are completely different routes. It doesn't care that the ending IP is the same. The route distinguisher makes the entire string unique. Now let's move over to the route target. The route target is what actually moves the data. It is the community string that switches look at to decide, is this for me? The route target must match on every switch. If VTEP1 exports within route target of 6500 colon 50,000, then VTEP2 must import with 65,000 colon 50,000. So again, if we have different VRFs, that's not going to be 50,000. It'll be 60,000, right? So if VTEP1 exports with RT or route target of 6500 60,000, then VTEP2 must import for that with 65,000, 60,000. So that's how it keeps everything the same, right? So that's how 50,000 will never talk to 60,000. So those VNIs that are in 50,000 will not speak to those VNIs that are in 60,000. So again, this is why we use the VNI in the auto calculation for route target. Since the VNI 50,000 is the same on every switch, the route target math comes out the same everywhere, creating that lock and key we talked about. So kind of to put it simple, imagine you're sending a package through the mail. This is the route distinguisher. It is a tracking number. It's a unique ID that the post office which is BGP, uses to make sure your package doesn't get mixed up with anyone else's package, even if they look identical. The route target, this is the access code written on the door of the destination. The post office, which is the spine, can have 1,000 packages with different tracking numbers or route distinguishers. But the delivery driver, which is the VTEP, will only drop the package off if the access code, the route target, on the package matches the access code on the building door. Alright, so now I'm going to start creating the interface VLANs, interface VLAN 10, 20, 30, and 500. I'm going to go ahead and put the commands on, and then we'll go through it. You can fast forward as I do that. Alright, so first command here is going to be the VRF member tenet A. Okay, so we're configuring the SVI, the switch virtual interface. This is the internal door, right? The VRF member tenet A. The internal door on the switch where your layer 2 world meets your layer 3 world. By default, every interface on this switch or layer 3 switch belongs to the global or default routing table. The command VRF member tenet A tells the switch, this interface, take this interface and pull it out of the default world and place it inside the private world of tenet A. So as you remember, we created the VRF context tenet A, right? This command is how you actually plug the cable, right, quote unquote cable, from VLAN 10 into that virtual router. So now VLAN 10 belongs in the routing table of tenet-A. And as you can see, we also put VLAN 20, 30, and 500 under the VRF tenet-A. So for the switch to route traffic from the Ubuntu desktop of 10.10.0.50 to another subnet of 10.20.0.60, it needs to look at tenet-A's routing table. If the interface isn't a member of that VRF, it will look at it and find nothing, basically. So it's gonna, well, we'll go over VLAN 500, which is basically the layer 3 part of all of this in a little bit. Next command are the IP addresses. We all know about that. The Nexus does allow us to use a /24 instead of putting the full subnet mask. So let's jump to the fabric forwarding mode anycast gateway. So this is the command that provides the magic in a modern VXLAN fabric. It's what allows your Ubuntu desktops to move from one switch to another without ever needing to change their gateway settings or update their ARP tables. In a traditional network, a gateway like 10.10.0.1, which would be here, this would be 10.20.0.1, that's how I configured it, and then 10.30.0.1. But we're talking about 10.10.0.1. The Anycast gateway changes the rules, right? If the router dies or if you move your PC to a different part of the building, you lose your connection. It tells every VTEP in the fabric to pretend to be the exact same router. Every VTEP will use the same IP address of 10.10.0.1 and the exact same virtual MAC address for VLAN 10. So let me try to explain this a little bit more. Basically, wherever you see a 10.10, the default gateway for that is going to be 10.10.0.1 for every single one of them, right? And also for every single one of them, you're going to have the fabric forwarding mode Anycast gateway. So what I just said applies here. Again, if you take your Ubuntu desktop and vMotion it from a server connected to VTEP 1 to a server connected to VTEP 2, the desktop doesn't realize anything happened. It still sees its gateway as 10.10.0.1 right there on the local switch. So that you can use vMotion for that, or you can physically do it if all of these, as we said before, are different buildings, right? You could take this desktop and move it over to this building, which would be VTEP 4, and that interface would then have to be configured also for the correct VNI. And if it is, then it's going to be seen as if it never moved, basically. Again, it prevents the Ubuntu machine from having to send ARP requests across the whole fabric to find its gateway. The local VTEP answers immediately. Alright, that's it for this video. In the next video, we'll start with Interface VLAN 500. This is going to be your Layer 3 VNI SVI. Alright, I'll see you in that video.